Next is 4 variable K-map. In 4 variable K-map, suppose you have an example like function of ABCD equal to sigma m, suppose 0, 1, 8, 9, 12, 13, 15, something like this. Okay, so first we'll draw the 4 variable K map. In a 4 variable K map, so this is your MSB. So MSB A, next variable B, CD. You'll be writing like this. Okay, AB, CD. So AB can take 4 values. So 1, 2, 1, 2, 3, 4. And CD also, since there are 2 variables, it can take 4 values, that is 0, 0, 0, 1, 1, 1, 1, 0. 2, 3 and 4. So how will we write this values? Like in the 3 variable K map, we'll write it as 0, 0, 0, 1, 1, 1, 1, 0, not 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. Then we'll write the values of each block. So 0, 0, 0, 0 will be 0, 0, 0, 0, 1 will be 1, 0, 0, 1, 1 will be 3, 0, 0, 1, 0 will be 2, 0, 1, 0, 0 will be 4, 0, 1, 0, 1 will be 5, 0, 1, 1, 1 will be 7, 0, 1, 1, 0 will be 6, 1, 1, 0, 0 will be 12, 1, 1, 0, 1 will be 13, 1, 1, 1, 1 will be 15, 1, 1, 1, 0 will be 14, 1, 0, 0, 0 will be 8, 1, 0, 0, 1 will be 9, 1, 0, 1, 1 will be 11, and 1, 0, 1, 0 will be 10. 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 12, 11, 10. So these are the values of the individual cells. So you should be knowing the values of these individual cells. Otherwise, you should write. Anyway, you should write all the cell values all the time. Otherwise, you might get confused. Now, we will write the 1 for mark 1 for each of these cells. So 0 you'll mark a 1, 1 you'll mark a 1, 8 you'll mark a 1, 9 you'll mark a 1, 12, 13 and 15. So according to the question, this is how you mark the values. Okay. So now what was the first rule? First rule was that all the ones should be mapped. Second rule was that maximum number of ones should be mapped in a particular group. Okay. So suppose you want to group these two ones. These two ones don't have any other ones in 4 and 5 to group or in 3 and 2 to group. So 0 and 1 can be grouped together, only two ones together, but it can also be grouped with 8 and 9 by the folding technique. Okay, so you can fold the K map. You can fold the K map vertically to form the quad. So you have this. So here you have 2 ones and here you have 2 ones. So you can fold it like this. Fold it like this, or better still here, here and here. So you can fold it like this. You can fold it like this. That is these 2 ones and these 2 ones together you can fold, because you want maximum number of ones in a particular group. So instead of grouping it as 2, you can group it as 4. That is better. Okay, so that is the first group. Now second group. Now you have 3 more ones to group. So these 2 ones, how can you group it? You can group it as a group of 2, but then again the rule comes that you must group maximum number of ones possible in a group. So here these 2 ones are already grouped. So we can say that a particular one can be grouped any number of times if required. If required, a one can be grouped any number of times if required. If required. If not required, don't group it. Okay. If required, it can be grouped any number of times. Okay. So these 2 ones, if it is grouped with these 2 ones, it will form a quad. So if that is required, then you can group it. So these 2 ones will be grouped with these 2 ones to form the quad. Now this particular one. This one can be grouped alone, but if it can be grouped with another one in 13, then that is better. So it is grouped with this one. Okay, so that is the best possible grouping. Now we'll write the values. So these 4 ones, first group. So that will be, so f equal to 4 ones. What is the common? 0, 0 and 1, 0. So B is common. What is B? B is 0. So that is B bar. Then what is common here? C is common. C bar. D is not common. So it is B bar, C bar. B bar, C bar. What is common for all the ones in a particular group? You will write it as a product. Then when you move on to the next group, you will put a sign, a plus sign. Then you will go to the next product, next minter. So next, suppose we are taking this 4. So what is common? A is common, B is different. So A is common. What is A? A is equal to 1. So A, and C again is common. So that is C is 0. So C bar. Again put a plus. This one, these 2 ones. So for these 2 ones, A and B is common. So that is A equal to 1 and B equal to 1. And what is C and what is D? C is different and D is same. So that is A, B, D. So this is my answer, B bar C bar plus A C bar plus A B D. Here you can see that it cannot be further reduced, because if we are taking the maximum number of ones in a particular group, if we are grouping in the most optimum way, then there is no need of again simplifying the equation further. So if you are able to simplify it further, then that means that the grouping, K-map grouping is not correct. So you will lose mark there. Okay. So that is what it is. Now suppose I am making a small change. Suppose this is 13 14, 15. Okay, so that will change the K map to like this, right? I'll just okay. So this is the question. I've so like okay, in the earlier case 11 was not there. Okay, 11. Okay, 12. Right, 12 is there. So 12 also 1. Okay, so here there is no change for this. These 4 ones are already grouped. Now how do you group these 2 ones? In the earlier case we grouped these 4 ones together because there was no other way to group it as a quad or maximum number of ones in the group. But now in this particular case, in order to group these 2 ones, you can group it as a quad like this. Yes. So this is the best possible way. So there is no need to group these with these 2 ones. Okay. In the earlier case, we were grouping these 2 ones twice. With these 2 ones and also with these 2 ones. Because that was the only possible way. But in this case, there is another quad available. So there is no need of regrouping these 2 ones again. So what will the answer be? It will be A bar F equal to A bar, sorry, B bar C bar, that is for these, plus what is this? AB. Right? Suppose your question is, say, A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So it is 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. So suppose my question is 0, 2, 4, 6, 8, 10, 12, 12, 14, 13, sorry, 13, 14, 15. Suppose this is your question. So it is 0, 2, 4, 6, 8, 10, 12, 13, 14, 15. Right? So this is your question. So here, if you see here the corners, these two sides, full it is 1. So you can fold it like this. You can fold it like this, right? You can fold it as an octet. 8 ones, octet. Okay, and these two ones, how can you group it? It is better to group as a quad. It is better to group as a quad, right? So what is the answer? F equal to what? Octet will give you AB, nothing is common. CD, D bar is common, plus this 4 ones, so that will be A, B. CD, nothing is common. So this is your answer, right? So this is a 4 variable K-map. Now suppose I'm getting a question like, suppose y equal to, y is the output, y equal to suppose AB plus B bar C plus CD plus AD. This is my function. In this particular function, I am asked to write the canonical form. Write the canonical form. So the canonical form is the way by which you write function of a, b, c, d equal to sigma m, some values. So you want to write it like that. So the easiest way to write this is, we'll just map this to a particular K-map. Okay. So here first you'll see how many variables are there. So there are A, B, C and D. So it's a 4 variable K-map, A, B, C, D. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Now, usually after putting the ones in the K-map and grouping it, you can write this particular expression. Now we are going to do the reverse. We are writing this particular expression. The expression is given to us. We have to mark in this particular K-map from this. So in order to get AB, which are the ones that should be grouped in order to get AB? So first we'll write the cell numbers 0, 1, 3, 2, 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. So AB, in order to get AB, which are the cells that should be grouped? AB means here 1, 1. So if there are ones in all these cells, then that will be grouped together to get AB. So where do we put the ones? We will put the ones in all the 4 cells. Yes, this together will form AB. B bar C. B bar C means B is 0 and C is 1. B is 0 and C is 1, so 0, 1. B is 0. B is 0 and C is 1. So B is in this area and C is in this area. So B0. B0 means this and this. and C1. B0 means this particular row and this particular row. CS1 means, C1 means these two columns, right? So this one, this one, this one, this one. So if you group it like this, fold and group, then that will be B bar C, right? That is, if we group like this, you will get AB. If you group like this, you will get B bar C. Next is CD, C1, D1. C1, D1 all should be 1. So here we already have some 1s. We'll keep it as such, and whatever is remaining I'll add. So this is CD. AD. So A should be 1. A should be 1 means A is 1 and D is 1. D1 means these two. This and this. So these two and these two. So here we have a missing one. Next we'll write the canonical form, that is y of ABCD equal to sigma m. Wherever you have a 1, we'll write those numbers. 2, 3, 7, 9, 10, 11, 12, 13, 14, 15. 2, 3, 7, 9, 10, 11, 12, 13, 14, 15. So this is your canonical form. So this is how you write the canonical form. Suppose you have another simpler example. Suppose y equal to AB bar plus BC plus A bar B. So here only A, B and C. So that's a 3 variable K-map. A, B, C. A can take two values 0 and 1. B, C 0, 0, 0, 1, 1, 1, 1, 0. And this is 0, 1, 3, 2, 4, 5, 7, 6. So A, B bar, how will you write? A is 1 and B is 0. A is 1 and B is 0. B 0 means there are two columns where B is 1. So this and this. So here 1 and here 1. This together is your A, B bar. BC. B is 1, C is 1. B is 1, C is 1. So here if you have two ones, it will be BC. A bar B. A is 0, B is 1. A is 0, so A 0 and B is 1. B1 means this and this. So here A bar B. So what's the answer? Sigma m y of ABC equal to sigma m 2, 3, 4, 5, 7. So this is your answer. So this is how you write the canonical form from the given Boolean expression. Now suppose you want to draw this. what you'll do is A, you have an A bar also, so here you put A bar, B, and you have a B bar, so again a NOT gate. C, you don't have C bar, so that's it. Now A, B bar, A, B bar. So that is an AND, which will give A, B bar. BC, B, C, that is another AND gate, BC. A bar, B, A bar, B, that is another AND gate, A bar, B. So you have to OR all these. So for theory purpose, you can just keep a single OR, but practically this is not possible because you don't have a 3 input OR. But theory purpose, this is enough. So this is AB bar plus BC plus A bar B. But practically this is not possible because a 3 input OR is not available. For theory, if you draw like that also, it's fine. So practically what you'll do is you have a 2 input OR gate. So you'll OR this. Here you will get AB bar plus BC. This another OR you'll use. So this will be AB bar plus BC plus A bar B. Or that's why. Okay. So that is how you express the Boolean expression in a K-map or in a canonical form, and how you draw the diagram. Now, next is SOP using NAND only. So if you have a sum of product means suppose you have an expression y equal to suppose AB plus BC, a simple sum of product equation. So this normally what you will do is A, B, C, AB, BC, then you will OR it. You will get AB plus BC. So suppose your question is like express this equation using NAND only. Then what you will do is you can't use AND and OR. So some SOP is always in the form of AND followed by OR. AND gives you the product and OR gives you the sum. That is sum of products, and you are taking the sum of those products. So AND OR combination is SOP. So for that, the best possible way to represent an SOP or a AND OR process using universal gate is NAND. Now I'll explain it with this example itself so that it's much more easier for you to understand. So you have A, B, C. So we'll take A, B. I'm giving it to a NAND, suppose. So what will my output be? A, B, whole bar. Next is BC. I'm just taking these products and giving to a NAND instead of AND. B, C. So I am giving it to another NAND. So this is B, C, the whole bar. Now what you have is A dot B the whole bar and B dot C the whole bar. What I want is AB plus BC. Now suppose I am taking the product of these two and again complementing it. So what happens is this becomes AB double bar plus BC double bar according to De Morgan's law. AB double bar is AB plus BC. So I have complements here. I need to just take the product of these two complements and then complement again. So dot and complement, that is another NAND. So here I am giving this to another NAND, so that what happens to the output is A dot B complement dot B dot C complement, the whole complement. So what I get here is AB plus BC. So whenever you have a AND OR combination or SOP, both are the same, you can replace it with a NAND combination. So this is a popular question. Express only using NAND. Okay, so AND OR is equal to NAND. NAND is equal to AND OR. Okay, so suppose I have another example. A bar B plus B bar C. So for here you need A bar also and B bar also. So A bar and B bar you can't use a NOT gate, you can use only NAND. So that also should be, NOT should be implemented using a NAND. Okay, so here you have A and this NAND will give you the NOT. So that is A bar. Here you have B and this NAND will give you B bar. Then you have C. You don't have a C bar. Okay. So A bar, B, you'll just simply take those products and give to a NAND. B bar C, B bar C to another NAND and then NAND. Give the final to another NAND. So this will be A bar B the whole complement. This will be B bar C the whole complement. This will be these two products. That is, here will be A bar B complement dot B bar C complement, the whole complement. So that will be A bar B double complement plus B bar C double complement. So that will be A bar B plus B bar C. That is your one. So this is how you implement an SOP using NAND only.